sequences. Okay. As it says there, a sequence is an ordered set. The terms in a sequence are often numbers. Okay. Most of the things we're going to deal with are numbers. Occasionally, I know in 7th grade and some on the achievement test, there'll be pictures. They'll do certain pictures, and they'll have a pattern to the pictures, and then they'll want you to establish what the next one is, or the next two is, or the next three is. Okay, and so basically what we're going to be looking at today is just different types of patterns. For the most part, they have a mathematical pattern. In order to have a mathematical operation that's being done to each one. Okay, and so they're going to want you to try to identify what the numbers, in this case, numbers will be in the future, or the next numbers that will happen. But I want to look at this example. It's out of your book. It's it's just a pretty common example when you deal with patterns and sequences. It says in the year 1202, a mathematician called Fibonacci made up a word problem about pairs of rabbits. The number sequence that was used to solve the problem became known as the Fibonacci sequence. Okay, and part of it is right there. Obviously, with patterns and sequences, they're going to go on forever if you continue them. Okay, because numbers are infinite. There is no end to numbers. Brandon can give me a number, and I can always add a 0 to it, and I get a different number. Or I can add any digit to it, and I can get a different number. And it's a higher number. So numbers are infinite. They never end. Okay, we could stand here the rest of your life, and you could sit there and count and never have a number to stop with. Okay, I don't know anybody that's ever done that. Hopefully there's not been. Hopefully they didn't waste their time sitting there counting for their whole life and then died. And that would be sort of a waste of time. So it says, so we're going to look at what Fibonacci looked at about pairs of rabbits. Okay, it says, suppose you have a pair of newly born rabbits on January the 1st. Okay, that equals one pair of rabbits, not one rabbit. Here's your little symbol up here. A rabbit picture equals one rabbit pair. Okay, does not equal one rabbit. It equals a pair of rabbits. All right. Then it says after the rabbits are 2 months old, the pair will start to produce a new pair of rabbits on the 1st of each month. Each new pair of rabbits follow the same pattern. If all the pairs of rabbits live, how many pairs of rabbits will there be on August the 1st? Okay. So it starts here. All right. And what it's saying is after it's 2 months old, it will produce another pair of rabbits. Okay, after the second month. So here it is. It produces another pair. Okay, then you get another pair, and it produces a pair. So in April, okay, in April we started out, and here's the numbers that they start out with. 1, 1, 1 and 1, then 2, then 3, and then 5, then 8, then 13, okay? As you look at April, and if you can't see that picture good enough, look in your book, because it's obviously out of your book. In April, how many pairs did they have? They had how many pairs? 3 pairs, 6 pair of rabbits. Okay, that is correct. All right, because April, 1, 2, 3. Okay, so you can follow along there. They have it in your book. Under step 1, it says January there's 1 pair of rabbits. February there's 1 pair of rabbits. Okay, March there's 2 pair of rabbits. April there's 3 pair. May there's 5 pair. June there's 8 pair. July there's 13 pair. Okay, now what's the pattern? What's the pattern of those numbers? So let me write them down for us so we can look at them. So we have 1, 1, 2, 3, 5, 8, 13. What's the pattern? Anybody know? Well, look at it. Try to figure it out. What did we do to go from 1 to 1? Oh, we did something. You added what? 0. So to go from 1 to 2, what did we do? Added 1. Okay. But what's 1 plus 1? 2. So to go from 2 to 3, you added the previous 2 months. To go from 3 to 5, next 2 months. Okay. So, oops, I better put that in black down there so we can see it. Okay, so to go from 5 to 8, you added 3 plus 5. To go from 8 to 13, you did 8 plus 5. Okay, so to go to August, which is next is August. To go from here to here, what do you have to do? Not 5 plus 8, 8 plus 13. So 8, to get to August, we had to take 8 plus 13. 8 plus 13 is what? 21. So in August, you had 21. So if I wanted to expand this out and go to July, we'd have to take 21 plus 13. So that would be 34 in July. So now you can see that they're exponentially increasing. Okay? We go to, not July, June, September. September's after August, not June. I was going backwards. So now we go to October. October would be 21 plus 34, which would be 55. So we started with 1 rabbit in January, and by September, or 1 pair of rabbits in January, and by October, we're going to have 55 pair, 110 rabbits. It's a lot of rabbits. A lot of rabbits for rabbit stew. Alright, so that pattern, not a real easy pattern to understand, but basically you're just adding the previous 2 numbers. So Fibonacci sequence is basically to figure out a number, the next number, you add the 2 previous numbers. Okay? And so that's what his sequence was. Alright, now, let's look at these numbers. Let's see here. 5, 20, 35, 50. And when they put 3 dots after it, that means that the pattern continues. Okay? Means the pattern continues. Alright, so our first step, step 1, is to identify the pattern. Step 2 is use the pattern to come up with the next 3 most likely numbers. Okay, so step 1 is we come up with a pattern. The pattern being, what are we doing mathematically to the numbers they have given us to get the sequence we've got. Okay? So what did you do to 5 to make it 20? Well, there's two things. Hang on, guys. Did I increase the number or did I decrease the number to go from 5 to 20? And we increased it, okay? We increased the number. So mathematically, the ways that we generally increase numbers is to multiply or add. Now, you can divide by fractions or decimals and increase the number, but for our purposes right now in 6th grade, we're not going to do that. When you see a number that is increasing, we're usually using multiplication or we're using addition to increase it. So, in this problem, are we adding or multiplying to increase the number? Okay? Either one. If we're multiplying or adding, you've got to be able to do it to the same thing must be happening to all the numbers or the sequence of numbers. Okay? To go from 5 to 20, I have two options. What's one of the options I can do to 5 to make it 20? Jonah. You can add 15. What's another option that I can do to go from 5 to 20? We can multiply by 4. Okay? So, what I have to decide is those are the two things that we're possibly doing to the numbers. What I have to decide is which one is true. Okay? Well, if I take 4 times 5, 4 times 5 is 20. But if I take 20 times 4, what would be my next number? 80. And that's not correct because my number is 35. So I got to look at the other pattern. 5 plus 15, 20. 20 plus 15, 35. 35 plus 15, 50. So there is your pattern. Okay? We are adding 15 to the previous number. Okay, so that's step 1. That's the pattern. Step 2 is to finish out the pattern for the next 3. So I have to take 50 plus 15, which is equal to 65, then 65 plus 15, which is equal to 80, and then 80 plus 15, which is equal to 95. So the next 3 in the pattern are 65, 80, and 95. Those are the next 3. That is what they want for your answer. Okay? All right, let's look at the next one. 5, 1, negative 3, negative 7. Okay, so 5 to 1, would that be increasing or decreasing? Decreasing. Okay, to decrease, we either subtract or we divide. Okay, we either subtract or we either divide. Now, to go from 5 to 1, what's one thing that I can do? Maya. Do what? Subtract by 4. What's the other thing I could do? Isaac? Not divide by 4. You're right, we divide, but what do we divide by, Jonah? Divide by 5. 5 divided by 5 is 1. Okay? 5 minus 4. So our two options then is 5 minus 4 is equal to 1, and 5 divided by, let me put it over here, 5 divided by 5 is equal to 1. So those two things fit the next number. But does it fit the number after that? Well, if we have 1 minus 4, 1 minus 4 is negative 3. Okay, negative 3 minus 4. Negative 3 minus 4, remember we have to change that to addition. Do the opposite of that, which is negative 4. And sure enough, that is negative 7. So that has to be our pattern. Both of them are not going to work. And as I can prove to you here, if I have 1 divided by 5, that would be 0.2. Okay, well obviously 1 to 0.2 is not what the pattern is. Okay, so the pattern is then that we're subtracting, and there's 2 ways we can put this. We're subtracting 4 from the previous number, or, because these two are the same thing, we're adding negative 4 to the previous number. Okay? Understand that those two things are equivalent to each other. Subtracting 4 and adding a negative 4 is exactly the same thing. Okay? We're really subtracting, but you know, we're having to subtract negatives here, so it's really adding a negative 4. So, to figure out the next 3 numbers then, we must take negative 7 and subtract 4. Well, negative 7 and subtracting 4 is negative 7. Change our subtraction to addition. Do the opposite of 4 behind it, which is negative 4. What is negative 7 plus negative 4? Negative 11. So there's your first one. Then I take negative 11 and subtract 4. And that would be negative 11. Change the subtraction to addition. Do the opposite of 4, which is negative 4. And that is negative 15. So what's our next number going to be? What? Negative 19. So there's your next 3 numbers. Negative 11, negative 15, and negative 19. Obviously, if you can see that pattern, you don't have to show that work. I'm just showing you the work to show you that what we're doing to the numbers. Okay, because everybody may not be able to see that pattern or think in their head without visually going through and doing it. Okay, now, this pattern here is not really a it is a mathematical it is a mathematical pattern. It is a mathematical sequence. But to go from 1 to 7, what did we do? No. We increased the number, so we added or we multiplied. What did we add? 6. And to go from 7 to 1, what did we do? Huh? Subtract by 6. Add by 6. Subtract by 6. So the mathematical pattern is that you add 6 and then subtract 6. And so therefore, the next 3 numbers, 7, 1, 7. Because if I add 6 to 1, I'm going to get 7 again. If I subtract 6 from 7, I'm going to get 1 again. Okay? So that's obviously a pretty easy pattern that obviously you could even say that, well, there's no mathematics to it. They're just alternating 1 and 7. Okay? All right, now, I want you to try number 4 on your own. Number 4 says 10, 8, 11, 9, blank, blank, and blank. And then 11, 14, 12. Dot, dot, dot. So try to figure out what the missing numbers are that go in the box. And there is a mathematical pattern here, as well as a sequence of what they're doing. Who has my 3 numbers for me? Noah, what's the first number? 12. That is correct. Jonah, what's the second number? 10. That is correct. Brandon, what's the last number? 13. That is correct. Now, the bigger question is, who can tell me the pattern? Isaiah, what do you think the pattern is? Do what? It's minus 2 and then add 3? Okay, yeah. 10 minus 2 is 8. 8 plus 3 is 11. 11 minus 2 is 9. 9 plus 3 is 12. Okay, 12 minus 2 is 10. Okay, so we're subtracting to go from here to here. We're subtracting 2. To go from here to here, you're adding 3. Subtract 2, add 3. Subtract 2, add 3. Subtract 2, add 3. Okay? So good. Came up with the pattern, came up with the numbers. Good job. All right, now, let me look here. Yes. 7, negative 14, not negative 4, negative 14. 28, negative 56, dot, dot, dot. Okay, 7, negative 14, 28, negative 56. So, I have to figure the pattern. Okay, it's a little deceiving because to go from 7 to negative 14, we would usually think that we're doing what? You're subtracting or dividing. Okay, but since we have positives and negatives involved, you can also, to decrease a number, multiply a positive number times a negative number, and that will decrease the value of it. Okay? So really there's 3 things here that I could have done. I could have subtracted, okay? I could have subtracted by negative 21. But if you subtract negative 14 and you subtract negative 21 from it, that's going to give you negative 35, and that's not the next number. I could have divided, okay, 7 divided by, well, no, not going to be able to divide it and get a negative 14. Okay, so what's the other thing I can do to 7 to get negative 14? Jonah?
7 divided by negative 2.
No, So that gives me negative 3.5. That's why we can't divide it. What? Yeah, multiply, okay. We multiply by negative 2. Yes. We can multiply by negative 2. 7 times negative 2 would be negative 14. Negative 14 times negative 2. So I take negative 14 times negative 2. That would give me a positive 28. Okay, if I take 28 and multiply by negative 2, that gives me the next number, negative 56. Okay, so to figure out the next three numbers, I take negative 56 times negative 2. That's equal to positive 112. Then I take 112, multiply by negative 2, and that gives me negative 224. Then I take negative 224 times negative 2, and that gives me positive 448. So these are my next three numbers. 112, negative 224, positive 448. All right, let's see if we can figure out this one. 4, 8, 3, 6, 1, 2, dot, dot, dot. All right, what's the pattern? Isaac? Okay, good. We multiply by 2, and then we subtract by 5. So we say 4 times 2 is equal to 8. Then we take 8 minus 5 equals 3. Then we take 3 times 2 equals 6. Then we take 6 minus 5 equal 1. Okay, and then we take 1 times 2 equal 2. Then we take 2 minus 5 equal what? Negative 3. Then I take negative 3 times 2 is equal to negative 6. So there's one number, two numbers. I take negative 6 minus 5 equal negative 11. And there's your three numbers. Negative 3, negative 6, negative 11. And once again, the pattern was multiply by 2, then subtract 5 from that number. All right, do number 9 on your own. Number 9. You have an answer, raise your hand. All right. Isaac, what'd you get for the next one?
I got 0.
What?
I got 0. Negative.
Well, you got 10 to the 0?
Okay, when I just put 0 because...
Now, you can't put 0 because 0 is an actual number. What'd you get, Jonah? Yeah. Or what's the next 3 numbers? Can't be 0. Maya. Close. Hang on. You're on the second number. Noah.
10 to the 0 power.
Yeah, 10 to the 0 power. I think y'all are saying it right. I don't think you were saying 0 is the next exponent, I think is what you were saying, but you were just saying 0. And it's 10 to the 0 power, okay? Yeah, it's 10 to the 0, 10 to the negative 3, 10 to the negative 6. Your homework is 13.2, 1 through 12, and then 16 and 17. 1 through 12, and then 16 and 17. You may go.